All right, welcome to the 5th lecture in the course. Today's lecture will not be that much writing on the whiteboard. It will be more about coding. And a small disclaimer is that I'm not a Java coding guru, so don't take the examples as good Java coding practices, but rather as examples on the architectural changes that we are making. And as usual, I will post these into the GitHub repository for the course, and you are welcome to contribute with your own implementations and bug fixes or whatnot that could happen. So yesterday we talked about the model view separation principle as a basic and fundamental way to separate an interactive system into two major components. One model that is responsible for the requirements, the implementation of the requirements, the actual computations, information storage, and such things. And the view that is responsible for the user interface. And the first task we will do today is to transform our old dice game that was a little bit semi-model view separated into a more pure model view separation using packages and stuff that are available in Java. So I have actually also made a few minor changes to the game. So we have our code, we have the dice game, and we have the dice game. Looks like usual. Contains two die objects. The die objects are rolled. We get a value, and if it's equal to 7, we return true in the play. And we can also, and this is new, we can get the values of the two different die. And the die class it's like it was before. It's basically some random rolling of the die and storage of the die value. And maybe the interface has gotten a little bit more complex. I don't know if you can call it complex, but it's looping now, so we can select to play once more directly in the interface. And if we type Q, then the game is quitting. So it's actually, and also we display a little bit more about the game, the actual values of the die. And it was, before it was just win or lose. So it was a little bit boring. So I have made a few improvements to add to the user interface. And now I'm doing remote desktop stuff, so I probably will get lost sometime. And I put all this in the model view dice game folder, and we try to compile. That's no problem, and we run. And as you see, we display the little welcome message. Hello, dice world. Any key to play, Q to quit. So we type any key here, H for example. Oh, I won. And we get that over and over and over again until we type Q, and then the game is quit. So, looking at this main function and this main class, you can almost already now see that it has a lot of responsibilities in it. It is the starting point of the application. So for Java, this is this function. In other languages, it might look a little bit different, but this is the starting point of the application. This is where everything begins. So that is one responsibility of the player class right now. A second responsibility is to create objects for the dice game. And the third responsibility is the user interface. Okay, no problem. And that is maybe a little bit too much responsibilities for one class to have. So the idea now is to separate this into a model package and move the rules into that package, and a view package, and separate out the user interface to that package. And to do that in Java, you need to create directories, because the package structure is mapped to the physical structure on the drive. And this can also be different in different languages. I know C++, you don't need to map the namespaces to the actual directories in the file system. I think C# also creates at least folders for you automatically in Visual Studio. So, okay, we have the model and we have the view. Those are the two major components. So let's take the model classes, the die and the dice game, and move them into the model. The class files we could just remove like that. And we'll make a copy of the player class, because it already contains a lot of the user interface, so I will just be modifying it, and now I will rename it also to something different. Console, for example. So let's close those and reopen this. So let's start by modifying the user interface. We need to rename it, of course, to console. And we need to specify the package. MV dice game U. This is the package of this type. We probably don't need to have it static anymore, and this is actually, oops, this is actually not what we want right now. Rather, we could just say, okay, play the game. And what game should we play? Well, we should probably send a game in here. That is pretty much it, I think. We will see later when we compile stuff. Yeah, I get some questions here in the chat. The class files and the Java files. The Java files contains the source code, and the class file is the bytecode that is compiled, the result of the compilation, and what you run. And the package is the same as the namespace in C#. So let's save that one. And just take the model classes. And we shall specify MB dice game, the package. It's also horrible to use a different keyboard. I think that is about it for that, and we should also modify this one. This is still the start of the application, but we do not need actually the user interface parts anymore in this class. Just actually need to create a dice game. And this is all user interface code, and that goes just into the view and play and game. Yeah, the MV dice game is the name of the start package, so to speak. Type 13. Thank you. So, okay, let's try and compile and just hold our thumbs. Oh my god, we must have some serious problem because it compiled immediately. Oops. So we got our class file, and there also got our class files compiled. So okay, let's try and run it. Yeah, wrong name. I probably forgot the in the player. Yeah, I forgot the package of this type. And here we have the game again. So we could just play. And quit. Are you with me? We split up the application into two main packages, the model and the view. In the view, we moved all the user interface code into the view. So in our console, in the view package, we have the system in read, we have the print lines, and stuff like that. That is a small API calls to the console API in Java. This could, for example, be the same thing as echoing HTML or reading information from the post or get variables in PHP. Yeah, we have not got to the controller part actually yet, and as you see, while the main class, the player class here, got a lot more focused on what it's supposed to do. It's supposed to start the application, create the main objects, and then let them have a go at it. So this became much better. This code is still a little bit messy, in my opinion. And as Svante here points out, the view in the model view separation principle can be regarded as both the view and the controller. So there is no separation of view and controller in the model view separation principle. For those of you who know what the model view controller pattern is. So we did actually keep the exact same functionality. We restructured the code, kept the same functionality, and this is called a refactoring. Yeah?
What is the R and the N in the state?
Yeah, this is a little bit of the Java console API funkiness because it would actually treat the return key as two separate events. So if you press the return, you would get kind of like 3 or 4 characters for that if you type something. So it's just a workaround to get rid of that. And /R is the ASCII code for carriage return and /n is new line. So that code is a little bit Java specific. It's really nothing to pay that much attention to. Do you think the code became a little bit more structured? I think so, because we got rid of the user interface code and could put that in a separate place, and everything seems to work out a little bit nicer. I'm getting a question here on the chat, I think. Can the main method contain anything more than just a run method? Yeah, well, it can. Technically, it can contain anything, but I think it's a good idea to let this starting point of the application do as little as possible, because this is something that will change probably between different languages and different platforms. So if you put a lot of code into the startup point, the risk is that this will become very platform dependent. So I prefer to just let it have the responsibility to start things up, create the main objects, and then let them run. Yeah, we could make a small new diagram over this this new implementation, so you can see how it is a little bit different from previously. So we now have two new packages, and in the UML, create a package like this. It looks like a file folder, and it should of course be closed, but I will write the classes in here first. We have the die, and we have the dice game, so that is the model package. Contains the die class and the dice game class. The dice game class contains two die named MD1 and MD2. So the other part we had was the new packet view. And this contained just the console type. Something like that. And what other class is the console dependent on? What other class does the console use? We can take a look at the code, of course, because the code contains all the information we need. And we can see here that, all right, we have an operation here called play, and into this operation we send an object of type dice game. We don't have any member variables here of any other type, but we have an argument to the operation. And this is actually displayed using another type of arrow in UML. It looks like that. And this is good, because this is what we wanted from the separation principle. It stated that, okay, we can have dependencies from stuff in the view to stuff in the model. That is legal. But if we would have an arrow in the other direction, we would have violated the principle, because then something in the model would be dependent on something in the view. So if you draw these diagrams and you look at the direction of the arrows, you can find out what is dependent on what. And we will take a closer look at the exact notation and stuff in coming lectures. And this last arrow, it's called a dependency, and it's a little bit different than from the associations that we are kind of like used to from the domain modeling. Yeah, I often did not include the player class because it's this startup point really. So especially now that we have the model view separation in place, I think it's not that necessary to include it in a class diagram. You could, of course, if you would like to. And it will just be outside here. And what are the types? Is the player class dependent upon? Can take a look at the code once more. Oops. Player. Well, it creates two objects of this type and of that type. No special arguments and no special member variables or attributes. So we would have dependencies in this case also. Because we created objects. Yeah, I think it's good to have it in the sequence diagrams because it kind of like represents the user interface. Otherwise, it would be kind of wonky to just start the sequence diagrams when doing design in that way. Or the user itself, yeah. Okay. Questions? Yeah.
I wonder why is that association played to a console?
Yeah, it's because it's not an attribute in the player class. It creates the object inside the main operation, and then it's thrown away. So if you create an object and do not store it in a member variable or attribute, then it's dependency. Otherwise,
That's
That's the difference. Yeah. Yeah. So the question is, if you send an attribute into the constructor of a type, and in the constructor you save it in a member variable, then it's an association. So as soon as you have a member variable of a type, you have an association to that type. And the role name is the variable name. We will come back to this also a little bit later. So, and if you would like to display just the architecture here, you would probably not include all the types, but you would have the package called model and the package called view. Oops. And you would have this dependency on the package level instead, and draw it on the package level. Because we had the dependency from a type inside the view, the console, to a type inside the model. The view package depends on the model package. This is a logical architecture. And as this also has a physical representation on disk, it becomes a little bit of the development view also, because it talks about the organization of the source code on disk. So in Java, those two become a little bit intertwined. All right. However, as you probably noticed, the code in the user interface could probably be further refined. And this is where the model view controller pattern comes in. So we will just take a moment and take a look at this pattern. And this is a pattern now, and it's not a guideline or principle, it's a pattern. And do you remember what the pattern was? It's like 23 hours ago we said it. Yeah, a standard way of organizing your application, maybe. If it's an architectural pattern, it could be. But what is a pattern? It's a named, abstract, problem, and solution. So we have the name first. The name model view controller, and we probably should start then with the problem. And maybe the main problem that the model view controller pattern solves is that we often encounter changes in our user interface. For example, if we have a requirement that we should have a very user-friendly system, we will probably need to change the user interface a lot, because it is very easy to write down in your requirements that, okay, it should be user-friendly, but you don't really know what that is before the users have actually tried the system and said that it's not. So we can anticipate a lot of changes in our user interface from the users. Another thing that could change our user interface is changes in technology. We might have a system that relies on very specific hardware or something like that we anticipate change in. So technology can also impose changes in the user interface. For example, we would like to support Oculus Rift, or we would like to support the newest graphics API in our game. Probably highly volatile, will change regularly, so it could be a good idea to look into the model view controller pattern then. And if we are to live on a highly competitive market, maybe we also need to evolve our user interface to use the latest and coolest look and feel available. So it might be also a competitive thing to strive for. Does not seem like the smartboard would like to play with me today, so it looks a little bit wonky. But we could also have the case where different types of users have different needs. We maybe have the user that needs a point-and-click interface. Maybe we have a power user that wants another type of user interface. For example, a more console-like user interface, or scripting abilities, or something like that. Maybe we have the problem that the same information should be presented in a different way. The standard example is you maybe have a spreadsheet, so you have some data in the spreadsheet, and it's in the form of a table, the data, and this should be visualized as a table, or maybe as a pie chart, and maybe as another type of diagram like this, bar diagram, bar chart. The same data visualized in 3 different ways. And also, changes in data should be immediately presented. This means that possibly a calculation or something takes a lot of time. 30, 40, 50 seconds. And when the computation is done, this data should be immediately presented to the user. And the visualization of the data should be changed when it happens. It could be a multi-user system. Some user inputs new data into our table, and when we look at the bar chart, it should immediately reflect those changes in data. So if we have any of these problems, these issues, then we should look into the model view controller pattern. I think I'll just do it like this. And you can see that I have taken a course in teaching because I use different colors. Problem is red and the green is the solution. And maybe not to a surprise to many of you, we should divide the system into 3 packages. The model, business rules, just as in the model view separation principle. The view, visualization, that is output, and low-level input. And by low level, I mean often you have in your API for output, you also have possibilities to collect input from your input devices. These are often not separated anymore. So, for example, you can read data from a text label or input field in your API, and this should then be part of a view because it's kind of like a low-level input. It's text input directly from the API. Typically, on the web, in PHP, you read from post and get, and that's data from a form that has been displayed in the web browser. In the console, this will typically be reading the characters from the console. You can see that life is not easy when it does this. So the last part is the controller. Interaction. That is execution of user scenarios. To take a simple example, you log into your website. The interaction is collect data from the user interface, the name and the password, send this data to a model that evaluates it, and depending on the result from the model, you tell the user, okay, you are logged in, or oh, no, there was an error, try again. So this flow of interaction is the responsibility of the controller. So we have this division into 3 packages, and the next thing is define some kind of mechanism to propagate changes in the model to the view and the controller. This is something that we need if we want changes in data in the model to be immediately presented. So we need a way for the model to tell the user interface something has changed, update yourself, or do what you want. And at the same time, keep the rule of model view separation. And that is, the model should not depend on view or controller. So we cannot have a direct dependency into that. And this solution is often the observer pattern that we will take a look at later in the course. Not observer. So, taking these rules and looking at a diagram over this, it will look something like this. You have the model package, you have the view package, you have a controller package, and the controller can depend on the view, and the view can depend on the model, and the controller can depend on the model, and the view can depend on the controller. So these are the legal dependencies in the model view controller pattern. So, and that is pretty loose, I think, in my opinion. So when I do this, I try to avoid this dependency. And if possible, at least make this one a read-only dependency. So the view is just allowed to read data from the model, not change data or execute functions. What's the time? Yeah. I think we will just continue a little bit more and we will take a break. So this is an overview of the model view controller pattern and how it would look in a UML packaging diagram. And there are a few different flavors of the model view controller package that try to do these kinds of stuff, and they're named a little bit differently. And I think I have a link on the course homepage there to a page that describes different kind of user interface architectures and what you should think about when you select them. So, okay. We have a few consequences also. What is good about the pattern then? You can of course have these multiple user interfaces. You can change user interfaces without changing the business rules, and we can have experts in user interface technology to code the stuff that they're good at without disturbing the guys that knows the problem domain. You can have synchronization of user interfaces. In a multi-user environment, you can have a change in the model and it will be propagated to all of the clients. It supports that type of propagation. User interfaces can change. It's framework friendly. A lot of you have probably heard about the model view controller package from different types of frameworks and stuff like that you have found. It's test friendly. Automatic testing is enabled very easily in the model because you don't have a user interface intertwined into the model, so you can test, you can write a test user interface, so to speak, so to automatically execute the functions in your model classes. If you're good, you could probably also automate the testing of controllers if you really pay attention to what you do in your controllers. And the views are still pretty hard to test automatically, as they are probably presenting stuff on the screen and taking input from the screen. Yeah, Sante is mentioning here the mechanism for propagating changes, and as I interpret what you write here, it's typically the observer pattern. We will take a look at this pattern a little bit later in the course, so I won't be talking that much about it right now. We have reuse of primarily the model or parts of it. Also, if we pay attention to what we do in our views, views can be quite reusable also. However, it is often hard to reuse the controllers. We have a nice mapping of requirements, design, and code. Because the controllers reflect a user scenario, and user scenarios are our requirements. So by taking a look at our user scenario, we can often quite easily find the controller to look in, and we can find what step in the controller, and we can find the code that is used in those steps. And this is really good, because when you get an error report or a bug report from someone, you can quite easily locate the starting point of where stuff goes wrong. So this mapping is a really, really powerful thing. On the minus side, the controller and view, the user interface, is quite bound to the model. You have a lot of dependencies, often from both the controller and often both from the view into the model. And requiring the view to not have knowledge of the model often creates a lot of code and a lot of overhead, so to speak, in the controllers. So it's quite hard to find reuse situations there, and changes in the model easily propagates into changes in the controller and the view. It is often quite hard to make the distinction and separation of what is a view and what is a controller. This is something that I find myself often struggling with. What should actually go into the controller and what should go into the view? And this is something that you need to often think about both once and twice before you commit to something. And it is easy that you get either really fat views with a lot of responsibility or really fat controllers that has a lot of responsibility. And finding a good balance between that is not the easiest task. The model can become user interface specific, because when you develop your system, you often have one kind of user interface in mind, and it is very easy to have functionality or data in the model that is not used actually by the model itself, but it's rather a user interface that uses that data, but it's so convenient to have it in the model instead. So the model becomes quite user interface specific. So when you change the user interface, you have a lot of functions that you don't use anymore, and maybe a lot of data that you don't use. For example, in a game, you might have textures on your game world, on your level. The level is probably part of the model because characters needs to move around on the level, and you have rules that executes on this level, and you fall down and collide with stuff. So that's definitely part of the model. But the textures are possibly not part of the model, because it does not matter if it's grass or if it's dirt, if it's green or brown. But that's rather a convenience for this particular user interface that's supposed to visualize the level using textures. If we switch to another platform, maybe we should not have those textures anymore. So that is also something to think about and at least be aware of when you add those functions and when you add those data, that you do it for a reason and you do it because it's convenient, but at the same time, it's a little bit of a violation of the architecture. For example, when porting a game to another platform, you might have quite a much larger task of converting your model because you have a lot of functions to convert, but they are not used in your new interface. And also something that could be mentioned is performance. Seems to have a problem with the N character. And that is related to this propagation mechanism. It is not that easy to create this mechanism in a way that is effective in all cases. You can have either a very high level of mechanism that says, okay, something has changed, basically. So the view then needs to find out, okay, what is it that has changed, and make a lot of function calls and investigate the model very deeply, and then find out, okay, I'm not supposed to visualize this. Or you can have a very detailed mechanism that says exactly what has changed, but then this mechanism will probably be quite much larger. It will have a lot of more detailed function calls, a lot more detailed arguments. So it will be bad in that way. And striking a good balance here is quite hard. All right, questions? So for the next lecture, we will convert our dice game to model view controller instead of just model view separation. But first we take a break. 15 minutes of a break.